Have you ever imagined a planet entirely covered by water, with waves taller than skyscrapers, orbiting a black hole? That's Miller's planet from Interstellar. It seems impossible, but behind this cinematic marvel lies a fascinating blend of real science and imagination. Astronomers have discovered exoplanets that could be similar, oceans covering entire worlds, some orbiting massive stars, and even black holes. In this video, we'll explore every aspect: tidal forces, time dilation, relativistic physics, and production secrets that made Miller feel real. Stick around, you'll discover that the line between science fiction and reality is thinner than you think. Miller's planet doesn't exist in reality, but the idea isn't pure fantasy. Scientists have theorized planets that could orbit black holes, so-called black hole planets. These planets would experience extreme gravitational forces, but under the right conditions, stable orbits are possible. Now imagine a planet entirely covered by water, floating around a massive black hole like Gargantua. Ocean planets, as astronomers call them, might be common in the universe. Their surfaces could be completely liquid, without continents. Nolan took these ideas and transformed them into a visually spectacular world, creating a what-if scenario that's scientifically grounded, a planet that is extreme, but plausible. What makes Miller unforgettable are the massive waves. In the film, they rise hundreds of meters, but this is more than visual spectacle, it's based on real physics. These waves are generated by tidal forces caused by Gargantua's intense gravity. When a planet orbits such a massive body, the difference in gravitational pull between its near side and far side stretches the planet, creating colossal waves and constant ocean movement. This is similar to how the moon causes tides on Earth, only magnified to an extreme degree. Every wave we see in Interstellar was carefully designed with the input of astrophysicists, ensuring that Miller's ocean behaves in a way that feels both realistic and terrifying. Perhaps the most mind-bending aspect of Miller is time dilation. 1 hour on Miller equals approximately 7 years on Earth. This occurs because the planet orbits Gargantua at relativistic speeds, close to the speed of light. According to Einstein's theory of relativity, time slows down significantly for objects in intense gravitational fields or moving at such velocities. For Cooper and the team, this means that every second is critical. While they are on the surface, decades pass for those waiting back home. Time dilation isn't just a concept in textbooks, it's a real phenomenon. In Miller's case, it's dramatized to show the emotional weight of decisions and the inevitable separation between loved ones. Miller isn't just about physics, it's about human resilience. The planet is inhospitable, giant waves, extreme tides, and distorted time create life-threatening conditions. Each step the crew takes is a calculated risk. Nolan uses this environment to amplify the emotional stakes. Cooper must return to his daughter Murph, and every hour on Miller costs him years with her. The planet becomes a character itself, a force of nature that tests courage, intelligence, and emotional strength. It's a perfect example of science and storytelling merging to create tension that keeps audiences on the edge of their seats. One of the most impressive aspects of Interstellar is how real science drives the story. Ocean exoplanets, tidal forces, and relativistic time dilation are all genuine concepts. Nolan's team consulted physicist Kip Thorne to ensure scientific plausibility. By grounding the narrative in reality, Miller feels believable, even when waves tower like mountains. Science here isn't just background, it's central to the plot, creating suspense while teaching audiences about the universe. This is what makes the film stand out, the blend of spectacle, education, and emotional storytelling. Bringing Miller to life required extraordinary filmmaking. Scenes were shot in Iceland, using frozen landscapes and water tanks to simulate an alien ocean. The actress playing the astrobiologist nearly suffered hypothermia in icy water, emphasizing the harshness of the environment. Special effects combined practical sets with CGI to create waves that look physically possible. Even the sound design, like the ominous ticking and ocean roars, was carefully crafted to reinforce tension and realism. Every decision, from camera angles to water physics, was intended to immerse viewers completely in the experience. Miller also introduces viewers to concepts rarely seen in mainstream movies. Black holes, relativistic physics, and tidal forces are often abstract, but here they have tangible consequences. The film shows how extreme gravity distorts space and time, and how orbiting bodies interact. While Miller is fictional, it sparks curiosity about real exoplanets, tidal locking, and gravitational waves. Scientists are actively studying ocean worlds and planets near massive stars, searching for signs of water, ice, or even conditions suitable for life. In a way, Miller inspires a new generation to ask, could such planets exist, and what would they be like? So, Miller's planet doesn't exist in real life, but it's rooted in plausible phenomena, ocean worlds, black hole orbits, tidal forces, and time dilation. Nolan turned physics into cinematic drama, balancing spectacle, science, and emotion. The planet tests human endurance while educating audiences on cutting-edge physics. And now I want to ask you, if you could explore a planet like Miller, knowing that 1 hour there equals 7 years on Earth, would you take the risk? Comment below, I want to hear your thoughts, and let's discuss how far you'd go to explore the universe.